Now I am going to explain very important point in the second chapter, solutions, and it is solubility. So by solubility we mean the amount of solute in grams present in per 100 gram of solvent. So it is defined as the amount of solute in grams per 100 gram of solvent. So it is amount of solute in grams per 100 gram of solvent to form a saturated solution. To form a saturated solution. So this is the basic idea about the solubility. That solubility is a parameter to know about the ability of a salt to being dissolved in 100 gram of solvent at a particular temperature. So by solubility we mean the amount of solute dissolved per 100 gram of solvent. So this solubility is very important point. It is very important criteria. So it is fixed. It is fixed for a solute at a particular temperature. At a particular temperature. So what we can say? Different solutes have different solubilities at different temperatures, and as the temperature increases, solubility increases. As temperature increases, solubility increases, and vice versa. That is, when the temperature is decreased, the solubility is decreased. You know this thing. When you take the case of sugar syrup in the sweets, so when the sugar syrup is hot or slightly it is lukewarm, we are unable to see the crystals. But when the temperature of the sugar syrup is lower down, or it is around the room temperature, then it starts appearing as a crystals of the sugar. Similarly, other point is in the pickles. You all must be knowing, in the pickles which are fresh, or the pickles which are not so old, they do not have the particles of the common salt. But when the pickles they become old, 1 year old or around it, then there is the appearance of the particles of common salt on the surface of the pickles. Why? Because in due course of time the moisture is lost, and when the moisture is lost, there is the increase in the concentration of the salt. Because when you prepare pickles, the moisture content is more, and due course of time it is lost by evaporation slowly by even very small amount, but later on there is the appearance of the crystal. So this is the concept of solubility, and solubility is very important factor in the solutions. Now coming to the different cases of the solubility. So solubility can be in three cases. First is dissolution. Dissolution means solubility, dissolution of solid in liquid. This is the first. The normal condition. This is the most normal condition. We prepare lemonade, we prepare secondary, so we dissolve sugar into water to get the solution as per our requirement. So it is the one condition, and simply it requires stirring of the sugar. So we stir, we use powdered sugar. So powdered sugar is dissolved quickly because the surface area increases when the sugar is taken from a powder. If you want to dissolve sugar candy or misri, we are unable to dissolve. Why? Because it has larger particle size and the surface area is less. So surface area is enhanced, surface area is increased in this manner in case of the powdered sugar, or this castor sugar. Now other point is dissolution or the solubility of liquid in liquid, and this you have the experience. We dissolve many liquids. We dissolve one oil into other oil. We dissolve one solvent into other solvent. We dissolve one liquid into other liquid. Like we dissolve rose syrup to prepare rose milk. So this is other, and so it is similar to the dissolution of solids and liquid, but except one point, that liquids are easily dissolved. Liquids are easily dissolved except the point that they are not having the opposite nature. Like we cannot dissolve organic solvent into inorganic. Like any oil cannot be dissolved. So like behaves like, similar behaves like. So you have to keep in mind that similar dissolves similar, and dissimilar is not dissolved. Dissimilar is not dissolved. So this is the second point. Now third point, it is about the dissolution of gases. Dissolution of gases. Gases in liquid. So the dissolution of gases in liquids, it is not so frequent, but it is very important part of our life. Like in case of cold drinks. So cold drinks are made by dissolving carbon dioxide at very high pressure into the water, or the whatever is the sweetened water, and different chemicals. So this dissolution of gases, it is affected by many factors, like the pressure. It is affected by the pressure of gas. Pressure of gas. This is the very important point. And you all have the experience when we open the lid of cold drink bottle. What happens? The CO2 fizzes out. CO2 comes out. So there will be the hissing sound, and we call fizzing. So CO2 fizzes out of the bottle because inside the liquid CO2 is present at very high pressure. So this is the first point, pressure of the gas. Now second point is the nature of gas. All the gases, they are not equally soluble. All the gases are not equally soluble in a similar liquid. Like CO2. CO2 is more soluble. Carbon dioxide is more soluble. Carbon monoxide is very little soluble. Nitrogen, oxygen, they are not so soluble. So this depends on the nature. It depends on the nature of gas. Then the nature of solvent. Nature of solvent. So nature of solvent also plays an important role in the solubility of a solvent. So by increasing pressure, more this gas can be dissolved, and it is studied under other point, and it is called as Henry's law. Now I am going to explain about the Henry's law. I am extending this explanation, and so I am going to focus on the solubility of gas in a liquid. This will be the focus point. So in continuation with the other factors. So here, solubility of a gas in liquid, it depends on the following points. And first is the temperature. So temperature is a very important point. And so as the temperature decreases, or as the temperature is decreased, more and more gases can be dissolved. So as the temperature is decreased, more and more gas can be dissolved. More and more gas can be dissolved. Why? Because temperature is a form of energy. And when the temperature increases, so the solubility of gas decreases. And so it is directly related with the solubility. Simple fundamental of the dissolution, that as the temperature increases, solubility is decreased. So this is the first point. Now second point is the nature of gas. So nature of gas is also an important point. As you know, all the gases, they are not equally soluble in any particular solvent. So this depends on the nature, and actually it is the ability of a gas to get dissolved, and they are held together, the molecules are held together by some attractive forces. It can be the chemical change also, like when there is the dissolution of CO2 into water. So there is formation of carbonic acid. So this is the reason that CO2 is highly soluble. Contrary to that, or opposite to that, other gases like the case of nitrogen, oxygen, hydrogen, they are carbon monoxide, they are not soluble, they are very little soluble, because there is no chemical change, there is no chemical reaction, just there is the physical bonding. But here in this case, there is chemical bonding. So this is the second point. Now third point, which is very important point, it is the pressure of gas. Now pressure of gas, as you have seen in this previous portion of this video, that by applying pressure, more and more gas can be dissolved, because it results into compression. So simply what we can say, by applying pressure, the amount of a gas dissolved in a solvent, increases, and vice versa. That when the pressure is decreased, so solubility decreases. And so this is very important point. And then it results into the origin of Henry's law. Now, next part, it is the extension of the solubility in terms of a law, which is very important law, and it is called as Henry's law. And William Henry, the person is William Henry, and the person is contemporary to John Dalton. And so according to him, the amount of gas dissolved in a liquid at a particular temperature is directly proportional to the pressure applied. So according to this law, the amount of gas dissolved in a liquid at a particular at a particular temperature is directly proportional to the applied applied pressure. So the amount of gas dissolved in a liquid is directly proportional. Amount of gas dissolved in a liquid is directly proportional. It is directly proportional. Amount of gas is directly proportional to the pressure of the gas. Pressure of the gas. So if we take the M is the amount of gas, and it is directly proportional to the pressure. So here M is amount of gas. Of course, it is expressed in gram. Amount of gas in gram. And so this pressure of gas. And of course, pressure is in which? Pressure is in atmosphere. So this is Henry's law initial. Now, further Henry improved his law by introducing the mole concept. In terms of mole fraction, Henry says that the partial pressure or pressure due to one gas or individual pressure. So the partial pressure of a gas, is directly proportional to the mole fraction. Partial pressure is directly proportional to the mole fraction of the solvent or the component. So this partial pressure P and this is X. X is the mole fraction of any component we can take. And so if we remove this, so P, it is the sign of proportionality is removed, so it is the KH into X. This KH is called as Henry's constant. Now this Henry's constant depends on the nature of gas. It depends on the nature of gas, and so it is very much important in different applications. Now coming to next part, the applications of Henry law. And Henry law is very simple. Simply that amount of gas dissolved in a liquid is directly proportional to the applied pressure, or it is directly proportional to the mole fraction. But its applications are highly important in our different spheres of life. And first is in making carbonated water or in making cold drink. You know this thing. By applying high pressure, you might have seen on the shops or around, the vendors who are selling in the streets or the roads like soda water or simply soda. So they apply very high pressure. They have the cylinders of carbon dioxide and they use their machine to dissolve more and more carbon dioxide. And so when we open the lid of a cold drink bottle or can, what happens? CO2 gas fizzes out or comes out. We say fizzing of CO2. And because the pressure of the gas CO2 is very high, and as a result it comes out. And the point is, up to what limit it will come out? You might be knowing. So there is a limit. When the pressure of CO2 in the cold drink becomes equal to the atmospheric pressure. Once again I am repeating, the amount of CO2 gas dissolved in the cold drink is very high by applying very high pressure, and so CO2 will continue to come out till the time when the pressure of the CO2 gas dissolved in the cold drink or carbonated water or soda water is at par with the atmospheric pressure, or it becomes equal to the atmospheric pressure. Till then it will continue, And the point when the CO2 becomes equal, so you might be knowing the cold drink from which CO2 has gone outside, it is called as flat cold drink. It is called as flat. It is called as flat cold drink. And flat cold drink means from which CO2 has been lost. And you all must be knowing it becomes tasteless. So taste comes with the CO2. So this is the one application. Now second application, you all must be knowing the deep sea divers or the scuba divers, they use oxygen cylinders with them. And so the oxygen cylinders, they are not with the pure oxygen. Actually, the oxygen is diluted with helium. So deep sea divers carry oxygen cylinders containing liquid oxygen diluted with helium. It is diluted with helium. Why? Because oxygen is more soluble at high pressure. Because the scuba divers or deep sea divers, very high amount of water is there. And so more and more amount of CO2 oxygen will be dissolved in the blood. Because solubility increases. But helium is less soluble. Helium is less soluble into blood even at high pressure. So what happens? When the persons, means when the divers, they come out on the surface, what happens? Suddenly the oxygen comes out from the lungs. And what happens? It leads to very painful body conditions, very severe pain in the body due to very quick very quick coming out of the oxygen, loss of oxygen from the lungs, from the body. And it was in old days, and so many deep sea divers, they used to die. And so to avoid, it is dealt with the helium, because helium is having much less solubility than that of oxygen. So it is in very fixed amount. Now third application is in animal body. And you know all that in our body, all the animals or human beings, the dissolution of oxygen in the blood, in the lungs takes place. And how it takes place? It takes place by the concentration gradient. The oxygen which has been, the air which has been taken from the outside in the inhale process, it contains more oxygen. The concentration of oxygen is more in the inhaled air, in the intake air. And the concentration of oxygen is less and the concentration of CO2 is more in the blood. So there is the diffusion, there is the concentration gradient. And so what happens? If we have this inhaled air, so inhaled air has more oxygen and it has less CO2, and blood in lungs, it has more CO2 and it has less oxygen. So what happens? The CO, this under highly complex process. It is basically due to the this respiratory enzymes and the carbonic anhydrase system in the body. So under, you may say, under proper biochemical condition, what happens? This CO2, it is given, and this oxygen it is given, and so this is due to the concentration gradient, and as a result this becomes residual air, residual volume, and so we are able to breathe, or our normal body activities go, and so this is in the animal body. Now, fourth point is about the higher altitudes, or at the mountains. At mountains, it becomes difficult to breathe. Why? Because at the higher altitude, as you move upward, the air pressure decreases, and when the air pressure decreases, the amount of oxygen present for us also decreases, and so it becomes difficult. And so the mountaineers carry oxygen cylinders, or they carry the oxygen support system for their survival, and so this is all about the applications of Henry's law. Now coming to the last part of Henry's law and the limitations of the Henry law, limitations or drawbacks. So first, it is applicable under ideal conditions only. Ideal conditions must be maintained. Even then, this law will be valid. And this ideal condition means it is low pressure. That is low pressure and high temperature only. So this is the first point, first impression. Second is the gases to be dissolved should not react with the solvent. There should not be reaction with the gas or the solute and solvent. If it is violated, so this law will be failed. So this is there should not be any chemical reaction in this. Now the third point is the gas molecules should neither associate nor dissociate in dissolution process. So neither there should be association nor there should be dissociation. The gas molecules should neither associate nor dissociate in the dissolution. So this is about the Henry's law.